Hey everyone, Tim Clapham here from hellolux.com with another quick tutorial for Cinema4D. And this time what we're going to do is we're going to take a look at creating some kind of organic type using MoGraph and the Metaball object. As you can see in the editor view here, I have part of the Lux logo, just the Lux letters, so that we can kind of concentrate on that part. Let's come up to the MoGraph menu, add in a cloner object, and what I'm going to do, I'm just going to add in a sphere by holding down Shift. And if we select this sphere, press T, and let's just scale that down, and let's set that sphere to just be, say, 6 segments, so it's a little bit quicker. If we select our cloner, what I want to do is set the mode to be object, and I'm going to grab my Lux extrude, and I'm going to drop that into the object slot. And you can see that by default, what happens is it distributes those spheres over the vertices of that object. Let's just hide that Lux extrude, and you can see that we have a sphere on every point of that object. If we come down to distribution, we can in fact set that to be volume, which is a little bit more interesting. And let's set up to about 1,000. And you can see it slows down a little bit, and now we have all of these spheres filling up the volume of our type. Now we could take this and we could place this into a Metaball, and that would give us some kind of globby effect. But I want to show you a different approach, and rather than using polygons for our Metaball, I just want to use a single point. So let's just switch off our cloner for now, and let's delete this sphere. I'm going to add in a polygon object, and I'm going to press C to make that editable and switch over to point mode. And you can see now that we have all of these 4 points that make up our polygon. So I'm actually just going to select 3 of these and delete them. So now we just have 1 point left. Just to keep things simple, I'm going to bring up my coordinates, and I'm going to set my X and my Z to 0, hit return, and that will just place that single point at the same point as its axes. We don't really want that to be offset from the axes. Now if we call this point and drop this into our cloner and then enable our cloner, we now have all of those points distributed within our Lux extrude, but you can't actually see anything. If we switch to point mode, you can't see anything because this is a generator, so it's generating virtual points and we can't really see them. We could press C on our cloner, and then we would end up with all of these points, and you can see now I've got 1,000 points, and if I select all of them, you can see all the points. So they're all the points that we couldn't see before. I'm going to undo because I don't want them to be actual objects. I want to keep the cloner there, so I've got the option of adding in effectors. I can change the count and the distribution. I can change the random seed, those kind of things. So you just have to kind of trust that they're there, and I know that they're there. But what we can do now is we can hold down Alt and come up, and let's add a Metaball. Okay, so we've added a Metaball, and you can see immediately that we've got this huge globule of geometry that's been created from all of those points. Now, the way that a Metaball works when you're using things like points and splines is that it creates a metasphere around each point, and you can actually control the radius of those metaspheres, and you can do that using a Metaball tag. We can also control elements on the Metaball itself, such as the hull value, and the higher we take this, the kind of tighter it will become around our points. So you can see as I increase this up to 1,000, we can now almost see our letters for Lux. Let's just undo that. We can also control the subdivision, and you want to be a little bit careful with this, because if you set it too low, and you can see I've gone down to 11 and I don't have any, and there you go, you can see it took a while to redraw because it suddenly has quite a lot of geometry. So let's set this to say 25 for now. You can see we also have a render subdivision. So if you want it to look the same in the editor as it does in the render, you need those 2 values to be the same. But for workflow, probably you're going to keep the editor subdivision a little bit higher, and you just need to make sure you do some test renders to the picture viewer so you can see the final quality, because it will look considerably different if those values change quite a lot. The other option we have here is exponential fall off, and this will use an exponential fall off between the metaspheres, so it's kind of more of an abrupt fall off. And if we enable that, we should see a better result straight away in this example. And you can see we now have our kind of Metaball reading out the word Lux. Of course, we've got our editor subdivision at 25, so it does look a bit clunky. You can see all the polygons and things there, but there's no reason why you can't take that lower, or an alternative would be to use subdivision surfaces, drop that into a hyperNURBS, and there we go. I'm going to undo that because I'm just going to stick with just the Metaball for now. So I mentioned a moment ago about the Metaball tag. If we take our point object that we have here, and let's choose tags, Cinema4D tags, and add on a Metaball tag. On the tag itself, we have negative influence, strength, and radius. Now, you can use negative influence if you have that on certain objects or points, and you can use that to kind of push into the Metaball, to take parts away, to almost like make it smaller. Not really make it smaller, but to you can use it to shape negative areas. We have a strength parameter. If you leave that at 100%, that means that the hull itself will be the same as the Metaball generates. But if you increase and decrease that, then you will increase the hull value and decrease the hull value. So we could increase this here, and you can see it has a similar effect to adjusting the hull value. But because it's on a tag, you can have several objects in here, so you can have different objects with different hull values, which means that you can kind of create detail or remove detail from different areas of the Metaball. Finally, we have the radius parameter, and the radius parameter refers to the metasphere that I mentioned before. And the metasphere is a virtual sphere that's created around the point itself. So if we set this to, say, 10, you can see now that the metaspheres themselves are half the size. So what we could do is we could take several of these point objects and put them in our cloner, and we can kind of randomize the size of them. So it means some of the Metaball spheres will be larger and some of them will be smaller. Now, the thing with MoGraph is it's a little bit clever in that we could actually interpolate between those sizes, and we can set our cloner to blend mode, and that will allow us to do that. Let me just create a new scene, and what I'm going to do is add in a sphere, and then I'm going to add in another sphere, and this one I'm going to set to be 5, and this one I'm going to leave at 100. And if we add in a cloner and drop both of these in, and let's set the Y to, we'll say 100. Let's have a look, and let's increase the count. Okay, so you can see there's our little tiny sphere and there's our large sphere, and at the moment it's set to iterate between those. But if we set this to blend, you can see that what happens is, depending on the count that you have, it blends between those parameters. So it's blending between the 5 radius and the 100 radius, and you can do this with any of the parameters. We could set this to be 6, and we can set the other one to be 24, and we'd see that as well. You can see here there are less segments, and as we move up, we end up with a lot more segments. And that's exactly what we want to do with our points. And the reason I'm just showing it with spheres is because we can't really see it with our points. The other thing that we can do is we can add in an effector. So if I choose MoGraph effector and add a random effector, rather than have random position, let's scroll down and let's choose random modify clone. I'll just pull this over, and if I choose random modify clone, you can see that it randomizes how that blend is distributed. We can also adjust the seed, and you can see now we're kind of getting random sized spheres. And that's the kind of theory that we're going to use on our Metaball. So let's just close this down. I'm not going to save this. Let's take this point and let's just duplicate it to create another one. I'm going to select the Metaball tag here and set the radius on this to be 50. Okay, and maybe let's set that to be 30. And this one is set to 10 and this one is 30. Let's set this one to say 5. And if we come to our cloner object and we set this to be blend, now that what will happen is it will blend between those two different values. If we grab our Metaball and let's set the whole value to say 300, and let's set our editor subdivision down to say 15. Now if we render, you can see that we're actually getting some larger parts on our Metaball and we're getting some smaller parts. If we take our cloner, choose MoGraph effector, and let's add in a random effector, uncheck position, I'm just going to select this Metaball and set this back up to say 30, just so it's a little bit quicker. Now on the random effector, we need to set our modify clone to be, say, 100. Okay, and now you can see that we're actually getting gaps in here, so perhaps this whole value is a bit too high, so I'm going to take this down. And of course, if you don't want to reduce the whole value, you want it to be quite tight, you can leave that, say, at 250, but you're going to need to maybe double the amount of points in there, so increase the count on your cloner, and you can see the effect that we're having now. The other thing that maybe is quite interesting is you can grab your random effector, instead of using random mode random, set that to something like noise. Now noise is animated, so if we press play, what will happen is we should see the whole thing kind of evolving. Now it's going to be a little bit slow and jerky because we have got 2,000 points in there and we're generating this Metaball. So let's just press stop, rewind. I'm going to check these. I'm going to set that back up to 10. I think 5 is maybe a bit too small. And let's set that to be, say, 40. And let's set the Metaball hull value to, say, 150. Okay, and now as we scrub to different points in the animation, you can see that the whole thing is kind of evolving. And if I just set my Metaball editor subdivision to, say, 60, so everything happens at a lot lower resolution, now we can press play and you can see that the random effector is randomizing those values of the Metaball tags, so the metasphere itself is changing radius, and as it does so, we're kind of creating this organic undulating text. That looks pretty ropey at this editor subdivision, but if we set this down to 5 and hit render and have a look, it's going to take a little bit of time to calculate all that geometry. Won't take too long, and we should see a lot more detail in our mesh. Okay, there we go, and you can see that that rendered in just over, well, 36 seconds. So, you know, didn't take too long. Obviously, we haven't got any shaders or lights or anything in there. Takes a fair amount of time, but we have got a very smooth mesh. We could probably get away with increasing that subdivision, maybe to like 7 or 8, and that will make the render times faster. But what you can see here is that we do have these kind of larger areas of the Metaball here, and then here we've got like much finer detail. So you're getting a more of an organic, unusual look to the Metaball itself, rather than that even regular globbiness that we all know Metaballs look like. So it's just looking a little bit more interesting. So I hope you enjoyed that tip, and that gives you some idea of alternative ways to use things like MoGraph and Metaballs. If you add in a few lights and maybe some interesting materials, then you could possibly end up with a result like this.